Bismillahirrahmanirrahim. Hello students, welcome to the Electrical Engineering channel. This lecture is based on streamlines and sketches of electric field. So electric field lines are not always straight as for point charge, line charge and surface charge. From previous lectures we have studied that the electric field lines always originate outward from the point charge or a line charge or a surface charge, and they are always orienting away from the source or away from the charge if we have a positive charge. If we have a negative charge distribution or a negative point charge, then the electric field lines will be oriented towards the source or towards the negative charge. So these are the orientations of electric field lines if for different charge distributions. So for a point charge, they are radially outward from the source or from this point charge. If we have a line charge, they are again oriented in the row direction. So these electric field lines will be targeted in all the directions from this source of charge, which is a line. If we have a surface charge, again the electric field lines will be originating from the surface, and they will be either in this direction or in this direction. So at the left side of the surface they will be in the left direction, at the right side of the surface they will be in the right direction. And in all these three uh, charge configurations, the positive charge is considered. If we had a negative charge, then these electric field lines were towards the source or towards the negative charge. So in all these cases, we have seen that the electric field lines or stream lines are straight, but in physical cases, curved streamlines can also be observed. So the equation of streamline can be found from solving this ODE, and this is the equation of the streamline, and this equation is valid for straight streamlines as well as for the curved streamlines. One example of curved streamline is the electric field within the capacitor. So this is a positive plate of the capacitor, this is the negative plate of the capacitor, and we can see that the electric field lines or the streamlines are straight and they are from the positive plate to the negative plate, here as well and here as well. But if we move towards the edges or towards the point where the plates of the capacitor are ending, we will be able to see the electric field lines which are curved in nature. So over here you can see these are the streamlines which are curved. Here the radius of curvature is further reduced, and similar curved streamlines are also observed over here. These are called fringing field lines. So these are called fringing field lines, and here the electric field is actually steady. So such streamlines which are curved in nature, the equation of these streamlines can be evaluated by solving this ODE. So dy over dx is equal to Ey over Ex. So here you can see three curved streamlines, and at any point on the streamline, the x and y components of the electric fields can be observed. And for example, at this point, we can draw the tangent at this point, and tangent actually shows the direction of the electric field, and this electric field has two components, Ex and Ey. And we can also know that the derivative of this streamline at this point is equal to Ey over Ex. So dy over dx is equal to Ey over Ex. If we solve this differential equation, we will get the equation of this streamline. So this streamline definitely will have a certain equation, and that equation can be derived by solving this ODE. So suppose we have a line charge distribution, and for simplicity, we have assumed that the line charge density is equal to 2 pi epsilon. And for line charge, we know that E is equal to rho L over 2 pi epsilon rho A rho. So by putting this value, E will be equal to 1 over rho A rho or 1 over rho square rho vector. So this can be written in Cartesian components as 1 over x square plus y square x ax plus y ay, and E is equal to x over x square plus y square ax plus y over x square plus y square ay. So this component is Ex, this component is Ey, and Ey over Ex will be simply equal to y over x, and this is equal to dy over dx. So this is ex, this is ey. So dy over dx is equal to y over x, or we can write dy over y is equal to dx over x. So we can solve this differential equation as L and y, natural log of y is equal to natural log of x plus natural log of constant, and this can be written as a natural log of cx. So whenever two logarithmic terms are added, uh, they can be written as a combined natural log of their arguments, which are multiplied together. So ln x plus ln c is equal to ln cx. So by taking the anti-log, y will be equal to cx. So this is the equation of the streamline. Here we have to find out the value of this constant, and we are given this point. So we can put the coordinates of this point into this equation. So say 7 is equal to minus 2c. So c will be equal to minus 3.5. So the equation of the streamline will become y equal to minus 3.5x. So we can solve one more example to do the practice and to get more familiarity with how to find equations of the streamline. So there is an electric field whose components are given over here. So E is equal to minus 8x over y ax plus 4x square over y square ay. So find the equation of the streamline passing through this point 1, 4 minus 2. So dy over dx is equal to ey divided by ex. So it will be equal to minus 1 by 2x divided by y. And we can gather all the terms, y terms at the left side and x terms at the right side. So minus 2y dy is equal to minus x dx. Integrating both sides, y square is equal to minus x square by 2 plus c. So it will become this equation, and we can evaluate the value of c by putting the coordinates of this point 1, 4 minus 2. So at the end we will get c equal to 33 by 2. So putting this value of c in equation 1, so y square is equal to minus x square by 2 plus 33 by 2. So x square plus 2y square is equal to 33 is a simplified form of this streamline equation. So in the second part of this example, we are given a different electric field vector, and E is equal to 2 e raised to power 5x y 5x plus 1 ax plus x ay. So here dy over dx is equal to ey over ex, and it will be equal to this y component divided by this x component, and we can gather all the y terms at the left side and all the x terms at the right side. So y dy integral is equal to x over 5x plus 1 integral dx. This integration of this term is very simple, but for this integration we have to do some substitution. So first multiply this equation, multiply and divide by 5. So 1 over 5, 5x over 5x plus 1. And again, this term can be modified by adding and subtracting 1 from the numerator term. So it will be equal to 1 over 5, 5x plus 1 minus 1 divided by 5x plus 1. So it will be equal to 1 over 5, 5x plus 1 divided by 5x plus 1 minus 1 over 5x plus 1. So it will be equal to 1 over 5 into 1 minus 1 over 5x plus 1. Or it can be written as 1 by 5 minus 1 by 5 into 5x plus 1. So y square by 2 is equal to integral of 1 by 5 minus 1 over 5 into 5x plus 1 dx. So the integral of this term can be evaluated very easily. So this is equal to 1 by 5x minus 1 over 5 into 5 natural log of 5x plus 1 plus c. And this is the final equation of this streamline. So this is 1 over 5x, and the integral of this term is equal to 1 by 25 ln 5x plus 1 plus constant of integration. Now let's put the coordinates of this point and evaluate the value of c, and it is calculated to be 7.87. So put this value over here, and this is the final form of the equation, and we can multiply this whole equation by 2. So this is the final form of the simplified form of the streamline. So that is all about our today's lecture on streamlines and sketches of electric field. And I hope this lecture was quite understandable to you. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.